So these are examples of electric field lines. You can kind of think of an electric field as an invisible electric river. If you dropped a test charge in this electric river, the electric field tells you what path that charge would follow as it quote-unquote floats along the electric river. Another analogy would be tossing a leaf into a breeze. The leaf travels through the air in such a way that would be described by the quote-unquote wind field that exists in the space that it travels through. You have to be a little careful with this analogy because many textbooks will say that electric fields don't flow. So this concept of like something flowing, it kind of breaks down. But in terms of what a charge would do if you dropped it into the space where an electric field exists, I kind of like to imagine just like, dropping a stick in a river. So this leads to the concept of electric field lines. These are ways to visualize electric fields caused by electrically charged objects. Since electric fields describe what a positive test charge would do if dropped in the field at any point, and since positive charges are repelled from other positive charges and attracted to negative charges, this all adds up to electric field lines pointing from positive charges and toward negative charges. And so here we have a positive test charge. This is similar to what I drew before. And you have the electric field on the left here, just pointing radially out, so straight out at all directions. But if you have a positive and a negative, this is the electric dipole situation that we had before, you have electric field lines pointing from positive to negative, and they kind of end up taking these curved paths that you see. So this is not dissimilar from the problem that we just went through, right? And so if you wanted to draw the field lines of this guy, it would look very similar, right? And so the test points that we were considering, it would you can overlay this electric field kind of thing over the dipole situation, and you can see that point C was kind of in this area here, and point A was somewhere along here, and point B was over here. So that's what we were solving for. And then another equally neat looking one is two like charges. This would be the same whether it was positive or negative. If it were negative, the directions would be different, but the shapes would be the same. And they repel each other. And so there's this kind of void space in the center here where electric field lines do not cross. So that's kind of neat. You can actually take ferromagnetic shavings, iron shavings, and place them on top of charges and stuff, and you can see these similar kind of shapes. We'll see a similar thing for magnetic field lines. All right, so next and finally is going to be Gauss's law.